Hello and welcome to this hackathon submission for the Celestia Mammothon in 2025. My name is Mike, and together with our team we've created this PxlProof protocol, and it's already live, so you can check it out on pxlproof.netlify.app. And what it basically does, or what it tackles, is the issue about image protection or just like tampering with images, how you can detect it. And we have done it in like a very secure and sort of zero knowledge manner, as I will be showing to you very quickly. So first of all, we should connect our wallets. I will just do it real quickly with MetaMask. Once this is done, I have already 3 different images, as you can see. The first one is the original one, the second one has been tampered with, just some drawings for the sake of presentation, and then one image is cropped. Now let's take the original image and publish this one. It will go through the backend, hash it multiple times, like into different hashes, and then we'll get a response. Now what happens here is, in the backend it will be hashed into the an A hash, D hash, and P hash. So the A hash is the average hash, which captures overall visual features by reducing the image to a small size, converting to grayscale, and computing pixel values to the mean. The D hash then detects changes in pixel gradients by comparing adjacent pixels, and the P hash, which is the perceptual hash, uses DCT, which is discrete cosine transformation, to eliminate high frequencies and focus on the structure. Now, enough about that. Let's look at the transaction on chain. We have seen that it has been called a smart contract. Let's view this one real quickly. It's a verified contract. You can look it up. It's a pretty simple storing hash contract, which can only be done through the paymaster we've integrated in our backend. And to read this contract, what is like interesting for most of us is to get all the hashes, and let's just take a quick look. Now let's copy it here, and we see that it only stores like hashing data. Let's look at the last one, which will be our image. Right until there, we have 3 hashes, which is the A hash, D hash, and P hash. Now what makes this very unique is that just based on those hashes, we can set like a threshold sort of, and yeah, just manipulate that, like have a threshold to tell how different the images can be, so it is false detected. But let's just see what would happen if we would want to publish again. We would get an image or a message that it's already on chain. Now the same is for verifying, but here you don't have to connect or authenticate via your wallet. Now let's use a different image, and for this one I will take the copy, which has the circle on it. Let's try to publish this one, and as you can see, the image has been already on the blockchain. So what happens here is it does not have to be like put on chain. It just compares the hashes from the ones on the blockchain and then reverts it. Now let's publish also the third image, which here is the cropped image, and we can see if we crop it, then yeah, it also shows that the image is already on the blockchain. Now the tricky part with this is that like cropping images to a very high extent, like if we would take this image, crop it that you would only see like this part of the image, then obviously you've lost too many features from the image itself, and then it wouldn't be detected as like a fraudulent image or one that has already been created by someone. Now, but this is a very powerful tool, and what our team has also done is try to use the succinct integration with zero knowledge proofs, but for that generating proofs on the most powerful machines, like we had an Intel core with 36 gigs of RAM, and also an M3 Pro chip with 18 gigs that run into timeout issues after more than half an hour. So yeah, those simple image validation could not be done. But as we can see here, the calculation was done very quickly by doing the average hash, difference hash, and perpetual hash. And because of that, we have like a very fast, secure, and also private integration, because all you can see is just the hashes on the blockchain and transactions that have been done through our paymaster.